converse theorem of chord theorem. Let's recall what's meant by chord theorem. Chord theorem says the straight line joining the center of the circle. The straight line joining the center of the circle to the midpoint of the chord. To the midpoint of the chord. That means the entire chord was bisected. The straight line joining the center of the circle to the midpoint of the chord is perpendicular to the chord. This is our chord theorem. I'll repeat once more. The straight line joining the center of the circle to the midpoint of the chord is perpendicular to the chord. That is our chord theorem. But in the converse theorem, this is telling something opposite to that one. The perpendicular drawn from the center of the circle to the chord bisect the chord. Okay, I'll repeat once more. If the midpoint of the chord and center of the circle were connected, the relationship was perpendicular. Here, from the midpoint of the chord, from the center of the circle, okay, from the center of the circle, when you draw a straight line, if this is perpendicular to our chord, the chord will be bisected. This is our converse theorem. Actual theorem says the straight line which is connecting midpoint of the chord and center of the circle, these two are in perpendicular relationship. But the converse theorem says the straight line which is connecting center of the circle and a point in the chord, it is not specifically indicating the midpoint, okay, somewhere on the chord. But if these two are perpendicular, from that we can come to a conclusion that this chord would be bisected. Chord would be bisected. Actual midpoint theorem. The straight line which is connecting center of the circle and midpoint of the chord would be perpendicular. Here, the perpendicular line drawn from the center of the circle to the chord bisects the chord. That is the converse theorem. Simple. Here we are gonna apply the converse theorem of midpoint theorem. So what do we need to do is, we need to find the radii of the circle. Radii means if P is the center of the circle, I can consider this one. Okay, this one as my radii. To find the radii, somehow we need to use the chord theorem or else its converse theorem. Here you can see the straight line which is coming from the midpoint of the circle, center of the circle to the chord is perpendicular. That means if this is perpendicular, the chord is bisected. This is the conclusion. If the chord and the straight line which is coming from the center of the circle are perpendicular, the chord is bisected. So from that we can get some kind of idea. If MN is 8 cm, you can see the entire length is 8 cm. So since it is bisected, the 8 cm would be subdivided into two portions. This length is 4. Okay. Another length, this one also 4 cm. Additional note was PX, that is 3 cm. So PX means this length. This is 3 cm. Here you can see this is I'll draw here. Okay. This is a right triangle. In right triangle, to find the length of the hypotenuse, we can use Pythagoras relationship. By using the Pythagoras relationship, you can find the radii of the circle. Before that, definitely you should identify which one is our radii. That is really important. Since P is the center of the circle, from the center to circumference when we draw a straight line, that is our radii. This is our radii. I'll use simple R. To find R, hypotenuse square, that is equals to adjacent square plus opposite square. R square remains 4 square is 16 plus 3 square is 9. R square is 25. I can write 25 as 5 square. From that you can find the radii of the circle as 5 centimeters. As simple as that. I'll repeat once more from the beginning. Since the given detail, the straight line is perpendicular to the chord. From that we concluded this is converse theorem of chord theorem. If those are perpendicular, the chord is bisected. From that only I identified the 8 was bisected, and thereafter by using 4 cm and 3 cm I found the radii of the circle. PQ and RS are two parallel chords. Okay, parallel chords. That means the perpendicular distance between those two chords is same. Parallel lines. There are parallel lines means the perpendicular distance between these two lines would be always same. We know that. From our grade 7 onwards, we know the characteristics of parallel lines. Okay. Then I'll read that. And O is the center of the circle. The radius of the circle is 10 centimeter. Radius is 10. PQ. PQ is 16 centimeters. PQ was 16 centimeters. SR is 12 centimeters. Okay. And radii of the circle was 10 centimeters. So I will connect here. Okay. When I connect here you can see a perpendicular line. When you connect a straight line from the center of the circle to the midpoint of the chord, those are perpendicular. From that we can create a triangle with the radii. We know radii as 10 centimeters. What is the half of the chord? If the entire chord is 12 centimeter, half of it would be 6 centimeter. So in this triangle, when you apply Pythagorean relationship, we can find the height, this perpendicular height. And thereafter, not only this one, again also you should find the perpendicular distance between these two chords, no? Both chords. So in that case, here also I will draw another triangle. The entire chord was 16. So if I draw a perpendicular triangle here, this is 8 and radii of the circle was 10. By using this, you can find this height also. Okay, this small length, the blue color length, I will mark it as simple x. This is simple y. You can use the Pythagorean relationship to find x and y separately. When we add x plus y, that is the perpendicular distance between these two parallel chords. So here, when we use Pythagorean relationship here, this is this is the radii. No? In here, I will apply Pythagorean relationship in the bottom triangle. Here we have y. This is 6 centimeter. Entire length is 12, but that is bisected by the perpendicular line. No? Here you should use this. So 10 square, that is the hypotenuse. 10 square equals to y square plus 6 square. 10 square is 100, that is equals to y square plus 6 square, that is 36. I am going to bring the 36 as a subtraction here. So that will become 64 equals to y square. 64 is 8. 8 square equals to y square. From that we can find the answer for y as 8 centimeters. Y is 8 centimeters. Likewise, when you use the Pythagorean relationship here, you can find x as 6 centimeter. 6 centimeter. What is the distance, perpendicular distance between these two parallel chords? That is our question. Here 6, here 8. This is the distance, no? This is the distance. So entire distance 6 centimeter plus 8 centimeter, that is equals to 14 centimeter. While writing these answers, definitely you should include the proper wording. The distance between these two parallel chords. Yeah. Distance between PQ, SR chords 6 centimeter plus 8 centimeter, both together 14 centimeters.